Hello everyone, welcome to my channel uLearn Education Online. Now in today's video we are going to see how to solve the problems based on the concept of amplitude modulation, modulation index and efficiency. In the previous video we have seen what is modulation and how it is calculated, and also the concept related to efficiency of AM signal and the basic amplitude modulated wave. Now let us see the problem that is given and how it is solved. Here it is given that the antenna current of an AM transmitter is 9 amperes when only carrier is transmitted, but it increases to 10.6 amperes when the carrier is modulated by a single sine wave. Find the percentage of modulation and also determine the antenna current when the percentage of modulation changes to 0.8. So in this problem, what are the given parameters? So the given parameters are antenna current of an AM transmitter is 9 amperes when only carrier is transmitted. It means it is a carrier current. So given IC is equal to 9 amperes and here this carrier current is changed to 10.6 amperes when it is modulated by a single sine wave. Means here the AM modulation process will occur and the current that given is an transmitted current, that is IT, which is equal to 10.6 amperes. Now what they have asked? They have asked to find the percentage of modulation. We know that the relation between the current and the modulation index, that is IT is equal to IC into square root of 1 plus m square by 2. So from this we can find out what is the modulation index. Whenever the value is obtained, after multiplying it with 100 we can easily get the percentage of modulation. So from this equation let us find out what is the m value and thereafter substitute the given values, that is. So here we can write IT by IC is equal to 1 plus m square by 2, which implies, just do squaring on both sides, we can get IT by IC whole square is equal to 1 plus m square by 2 whole power 1 by 2 and it is whole square. So 2 gets cancelled. So finally we will get it is IT by IC whole square is equal to 1 plus m square by 2. Now solve this equation in order to get the value of m. So that is, we can write IT by IC whole square minus 1 is equal to m square by 2. So from this m square can be written as 2 into IT by IC whole square minus 1. So therefore modulation index m value is square root of 2 into IT by IC whole square minus 1. Now simply substitute the value of IT and IC. What they have given the value of IT and IC? IT is 10.6 amperes and IC is 9 amperes. Now substitute the value. So it will be, which is equal to square root of 2 into 10.6 by 9 whole square minus 1, which is equal to square root of 2 into 1.387 minus 1, which is equal to square root of 2 into 0.387. So use your calculator and we can finally obtain the value as 0.879. So since in the question they have asked percentage of modulation, so it means they have asked the value of percentage of m. So now simply multiply this 0.879 into 100. We will get finally 87.9%. So finally, for the given values of transmitted current and the carrier current, the modulation value will be equal to 87.9%. We can write the approximate value as 88%. Now let us see what is the second one that we have to find. So here we have to find the antenna current, nothing but the transmitted current when the percentage of modulation changes to 0.8. Since we know that even if the modulation value changes, there is no change in the carrier current. So here they have given the value of M as 0.8 and IC as 9 amperes. By using this formula, we can easily obtain the value of antenna current. Now let us solve this. So for the B problem, they have given the M value as 0.8 and they have given the IC value, that is carrier current, as 9 amperes. We have to find the transmitted current or antenna current. As we know that the IT value is IC into square root of 1 plus M square by 2. Now simply substitute these values in this equation. Finally we will get the value of IT, that is IC is 9 into square root of 1 plus M is 0.8 whole square by 2, which is equal to 9 into square root of 1 plus 0.8 square 0.32, so which is equal to 9 into square root of 1.32. Now substitute this value or using calculator find out this value. So finally its value is 10.34 amperes. So for the given modulation index and the carrier current, we obtain the transmitted current or is 10.34 amperes. So this is how we calculate the given problem with the concept related to modulation index and also the transmitted current. Thank you.